Jai Hind everyone. My name is Manoj Kumar, Assistant Professor, Department of Computer Science and Engineering, Akgec Garg Engineering College, Ghaziabad. Today, in this video lecture, we will learn about insertion in circular linked list. This is the table of content that I will cover in this video lecture. First, we will see the introduction of circular linked list, what is circular linked list and how we can represent a circular linked list. After that, we will see different cases of insertion operation in circular linked list, such as insertion at the beginning of circular linked list, insertion at the end of circular linked list, and insertion after a given node in a circular linked list. So let's start with the introduction of circular linked list. Actually, circular linked list is a type of singly linked list, but mainly difference is that the last node of the linked list is connected to the first node. It means in circular linked list, we are able to reach from the last node to the first node of the linked list. This is the main advantage of the circular linked list. A single linked list in every node point to its next node in the sequence, but the last node point to null. Suppose this is a linked list, but if this will be a singly linked list, then this pointer will be the null, because this is the node 2, this node 4 is the last node of the linked list. So in case of singly linked list, the address field of this node will be null, but in case of circular linked list, the address field of the last node of the linked list, that will contain the address of the first node. So in this way, this last node is connected to the first node. Okay, so address field of the last node is basically contains the address of the first node of linked list. So in this way, it make a circular linked list. So in circular linked list, every node point to its next node in the sequence, but the last node point to the first node in the linked list. It means address field or the next pointer of the last field basically contain to the address of the first node. So note that there is no null value in the next part of any node. This is the another advantage of circular linked list, that no address field of any node doesn't contain null. Every address field of every node is utilized to point to the next node in the linked list. First, we will see the insertion operation in circular linked list. It means if this is a circular linked list and now we have to insert a new node, then what may be the possible cases of insertion and what may be the different type of scenarios to insert a new node in the existing circular linked list. So first, we will see case 1 is the insertion a new node at the beginning of the circular linked list. Suppose a circular linked list is given and now we have to create a new node and insert that node at the beginning of the circular linked list. So to insert a new node at the beginning of circular linked list, we basically follow the given step. Step 1, first we create a new node. To create a new node, basically we use the structure pointer, or after that we will allocate the memory to newly created node. We can use the malloc function to allocate the new created node. Then we will assign the data field. Every node basically contain two field. First field is the data value field and second field is the address field. So whatever new node we are going to create, we have to assign the value to data field of that particular node. So once the node is created, memory is allocated to the node and the data value is assigned to the node. So after completing these three steps, now we are going to insert that newly created node at the beginning of the circular linked list, and for that we have to use the step 4. So to add new node in the beginning of circular linked list, set the next pointer of new node as head and next pointer of last node with new node. It means this is the scenario. Suppose this is our circular linked list in which the first node is this, which is pointed by the head, and this is the last node. Now we have to create a new node. This is the new node that we have created. Now our task is to add this newly created node at the beginning of that particular circular linked list. So for this, what we will do in step 4, to add the new node at the beginning of the circular linked list, set the next pointer of new node as head. It means initially we have initialized the address field or next field as null, but when we will add this new node at the beginning of new node, then we have to update it from null to head. It means the address field or next field of new node will point to the head, because head always refer to the first node of the linked list. Okay, so we will update this null field to the head. So in this way, this node will be connected to the first node. Now, since initially this is the circular linked list and the last node contain the address of first node. So whenever we have added this new node as the first node, now at the beginning of the circular linked list, now this becomes the first node of the linked list. So we have to also update the value of address field of the last node. It means we have to, what we have to do, address field or next field of the last node should now point to the new node. Okay, next pointer of the last node with new node. So we have to update this to the new node. Okay, again, since now this becomes the first node, so head will always point to the first node. So we have to also change the reference of head. Here head is referring to this node, but now when this becomes the first node, so we have to update the head with new node. It means head equal to new node. So this is the basic concept to add a new node in the beginning of the circular linked list, and this is the pseudocode, or this is the basically function, simply programming steps to add a new node. This is the function insert at the beginning. So first we create a new node, this. After that we allocate, in this step we are allocating the memory to newly created node. Then we have assigned the data field of new node with the value whatever we want to assign. Like for example, here the value, data field value is 1. After that, initially the next field of new node is initialized with null. Okay, now temp address arrow next node equal to head. It means until we have to, since we are going to add this new node at the beginning of the circular linked list, so we at first we have to reach at the last node. Okay, because address field of the last node is pointing to the head. After that, once we reach there, then temp arrow next equal to new node. When temp will refer to the last node, then we have to update the next field of last node with the new node. Okay, then new node arrow next is equal to head. This is new node arrow next pointer will point to the head, and once this is added, then we have to change the reference of head pointer. For that particular purpose, we are going to initialize head with the new node. So head equal to new node. So this is the basically code to insert a new node at the beginning of the circular linked list, and this is a graphic design which represent how we can add a new node in the beginning of the circular linked list. Next case is inserting a new node at the end of the circular linked list. Whatever step we should follow whenever we have to add a new node at the end of the circular linked list. So these are the steps. First, we will create a new node. Again, allocate the memory to newly created node. In third step, we will assign the data field value of the newly created node. And using the step 4, we will, once the node is created, memory is allocated to the node, data field value is initialized of the new node. After that, we will use step 4 to add that particular node or newly created node at the end of the circular linked list. So to add new node in the end of circular linked list, set the next pointer of last node with new node and set the next pointer of new node with head to connect it with the first node of the linked list. Let's understand step 4 with the help of the diagram. Suppose this is the circular linked list. Initially, there are 3 nodes, node 1, node 2, node 3, and this is the first node. So head is referring to the first node of the linked list. Now we have to create a new node. Like this, we have to create this new node and we have to add this new node at the end of the linked list. So to create a new node, first we declare it. Here node is the structure which contains 2 field, data field and the next field. So to create a new node, we will use this syntax, struct node asterisk new node, and asterisk temp. We are again using the temp pointer to come to traverse the linked list or to come at the last of the linked list, because we are going to insert the new node at the end of the linked list. So at first we have to come till the last node, because after last node, at the end of the last node, we are going to insert the newly created node. So for that purpose, we have to traverse the linked list, and to traverse the linked list, we have to use this temp pointer. So again, temp is initially initialized with head. So temp initially when we will traverse the linked list, then we will always traverse it from the first node. So since head refer to the first node, so temp is initialized with the first node. In this step, we are allocating the memory to newly created node with the help of malloc function. So here the node is created, new node, in this step the memory is allocated to newly created node, and now in this step we are assigning the value to the data field of new node, which is passing through the parameter to the function. So whatever value we will pass, that value will be assigned to the data field of newly created node. In this step, new node arrow next is equal to null. It means initially the next pointer, or we can say that the address field of the new node initially contain null. So yeah, it means this node is created like this, 5 value is assigned, and initially it contain the null. Now we have to add this new node. This is our new node. We have to add this new node at the end of circular linked list. So at first we have to traverse the circular linked list till the end. For that purpose we are using the temp. Since temp is initialized with head, so temp will point to the first node initially. So this step, temp arrow next node equal to head, this is the condition this represent to come to the last node. Okay, so temp equal to temp arrow next. So initially temp, this condition is not satisfied, so again temp equal to temp arrow next. Now temp will point to this. Now when again temp equal to temp next, so when temp will refer to this node, then this condition is satisfied and program control will come out of this loop, while loop. Now this step will execute, temp arrow next is equal to new node. It means once the temp pointer refer to the last node of the linked list, then this step will be executed. So temp arrow next is equal to new node. It means this is the temp which refer to the last node. So now we will update its next pointer. Initially the next pointer of this field is pointing to the first node, but since we are going to add a new node after the last node, so we have to update it. So now the temp arrow next, this will point to the new node. It means we are connecting the newly created node at the end of current last node of the linked list. So we will update it. Okay, after that new node arrow next is equal to head. Initially this is the null, next pointer of new node is null. Now we have to update it to make the linked list circular, because whenever this newly created node will be added to the end of the circular linked list, then now the next pointer of this node should refer to the first node of the linked list. And since the first node of the linked list is always represented by the head, so new node arrow next should point to the first node. It means new node arrow next should be initialized with head. It means address field or next field of the new node must contain the address of the first node. So in this way this newly created node will be added at the end of the circular linked list. So to add or to insert a new node at the end of the circular linked list, these are some steps, and this is the graphical structure or diagram how we can add a new node at the end of the circular linked list. This is the pseudo code, or this is the simply code, C programming code to insert a new node at the end of the circular linked list. Now third case, insert a new node after a given node in circular linked list. How we can add a new node after a given node, or we can say that after a specified node. For example, suppose this is a linked list. Now we have to insert, this is our new node. Now we have to insert this new node after node 2. This is node 1, this is node 2, this is node 3. Now we have to insert this new node between node 2 and node 3, or we can say that we have to insert new node after node 2. Then how we can do that? So to insert a new node after a given node, we have to use the following step. First we have to create a new node. Whatever we are going to insert, then we have to create that particular node. After that we will allocate the memory to newly created node, then assign the data field value to newly created node. So initially by using 3 steps the node will be created like this. 5 data value is assigned and this will contain the null. This is our new node. Now we have to add this new node after the given node. So to add this node after a given node, at first we have to come that particular node after which we are going to insert it. Like for example, we are going to insert this new node after node 2. So at first we have to traverse the linked list till this particular node, because whenever we add this new node after n2, then this pointer, this field will be update and this field will be update. Okay, so at first we have to come n2. So for that particular purpose we have to traverse the linked list. So to come n2, what condition we can use? We can use the condition to match with the data field value of the node, after which we are going to insert the new node. So for that particular purpose we will use this step: enter the data field value of the node after which we want to insert the new node. It means for that particular specified node after which we have to insert the new node, we will enter the data field value. We will use at the condition for matching to reach at the specified node. So once we reach that, then we will use the step 5. So for that particular purpose we define two pointer, temp1 and temp2, and initialize both of them with head. It means here in this case we have to traverse the linked list, and to traverse the linked list we are going to initialize two pointer, temp1 and temp2. Both pointer are initially referred as the initially initialized with the head, and move temp1 and temp2 until temp2 represent the node that after which we have to insert the new node. It means initially this is our temp1 and this is also our temp2. So we have to move temp1 and temp2 in this way until temp2 refer to this node, after which we have to insert the new node. Okay, and temp1 should refer to this node next to temp2, temp1. Okay, so what we are going to do here, we initialize two pointer, temp1 and temp2, and initialize them with head first node. Now we are moving temp1 and temp2 until temp2 refer to the node after which we have to insert node. For example, here we have to insert the new node after n2. So temp2 will move from first node till temp2 refer to the n2, and temp1 will move next to the temp2. So whenever temp2 started to represent n2 and temp1 next node to n2, now we are at the position or at the location where we have to insert this new node. So to insert this new node, what we will do, temp2 arrow next is equal to new node, and so initialize with head. Now traverse the linked list until the temp2 refer to the node after which we have to insert the new node. So once we, for that particular purpose we are using these steps: temp2 equal to temp1 and temp1 equal to temp1 arrow next, and loop will execute until temp2 arrow data not equal to num1. It means this condition is used to reach at the node, specified node, after which we have to insert the new node. So once we reach at the correct position, it means once we reach, suppose we have to add new node after n2. So once we reach n2, now for that particular purpose we are using the pointer temp1. So once temp2, so once temp2 refer to the n2, then to add new node, what syntax we can use here, temp2 arrow next equal to new node. It means now this will be disconnected and this next field point to the this. Okay, now again to connect this new node with temp1, what syntax we can use? We can use new node arrow next equal to temp1. Okay, so when this null pointer will be updated with temp1, so new node arrow next equal to temp1. So similarly these two steps we are using to connect new node between node n2 and n3. So temp2 arrow next is equal to new node and new node arrow next is equal to temp1. So in this way we can insert a new node after a given node in the circular linked list. For inserting a new node, these are basically three scenarios. First, insertion at the beginning, second, insertion at the end, and third case is the insertion after a given node in circular linked list. Okay. There may be a fourth case also, insertion before a insertion before a specific node or before a given node, but that is similar to the case 3. There is no more difference. Okay. Some time they will ask the questions related to that, insert a new node at a specified position, like for this, suppose this is a linked list. So this is at position 1, this is at position 2, this is at position 3. Now the same case, case third, insert a new node after a given node in circular linked list. This case may also be asked in the form of that, insert a new node at a specified position in the linked list. Again, for that purpose, we have to traverse the linked list till the position. Suppose this is node 2 and this is node 3. Now we have to add this new node at position 3. Suppose we have to add this node at position 3. So this is first node, this is second node, this node is at first position, this is at second position, and currently this is at third position. Now we have to insert this new node at third position. So again, the case will be, what the case will be, we have to insert this new node after node 2. So again, similar step we can use here. So for that particular purpose, this is suppose this is node 2. So n2 arrow next is equal to new node, and new node arrow next equal to n3. So by using the similar steps, we can use the we can insert the given node after a we can insert a new node after a given node, or at a given position we can insert a new node. So in this lecture we have learned initially about the introduction of circular linked list, what is circular linked list and what is the main difference of circular linked list and singly linked list. In case of singly linked list, the next field of the last node will contain the null, but in case of circular linked list, the next field or address field of the last node always point to the first node. After that, we have learn about different cases of insertion in circular linked list, like inserting a new node at the beginning of circular linked list, inserting a new node at the end of the circular linked list, and inserting a new node after a given node or before a given node or at a specified position in the circular linked list. Okay, thank you.